individual parts. If you're buying 1 or 2 parts at a time as they go bad, it's gonna cost you a lot of money to maintain the upkeep system. But then who wants to buy in bulk if you've only got a couple of small little systems? You know, yeah, I know, like, you buy everything in bulk, kinda drives me nuts, but I'm glad because I break a lot of stuff. So, these systems, once they do start to malfunction, or get clogged up, or anything of that nature, once that starts, you can pretty much bet your cookies that you need to go in and pretty much check everything. You might as well, because once you start doing a maintenance process on it, just check the whole entire system.
Because you're already there.
Because you're already there. Very good. Thank you very much, sir. I appreciate that. Okay. Let's move on to NFT. Nutrient film technique. Probably the most popular, widely seen on the internet way of growing plants. It's basically setting plants in little nets and having a little stream run up underneath them full of everything that they need. And it will produce the hell out of plants, especially lettuce, kale, again, non-fruiting plants usually, but some fruiting plants will do well in an NFT system because those roots are essentially just submerged in what that fruit needs, right? So they'll get everything that they need in an NFT system. They're pretty easy to set up. We kind of hybridized in one of our designs the theory of the NFT channel. And it was so easy that basically I probably could have got my 10-year-old to come out and install it. It's a very, very simple system to install. In the NFT channel, you have very rapidly fast-growing plants. Each plant generally is going to yield larger amounts of fruit, or the plant will be ready for harvesting and production usually around 15%, which is a very conservative estimate. I like to do all of my estimates conservatively, but if you can get a 15% cut on your production yield time, well then at the end of the year that kind of adds up, especially if you're looking at commercialization, right? So you take that 15% and multiply it by however many units you have, and that's a pretty good profit margin at the end of the year. Very little waste. Everything grows usually pretty strong. You don't have a lot of soil. You're not having to utilize other types of growth media. And once the growth media becomes muck, throw it away or try to compost it or something of that nature. You have a net pot, you have a plant, you have a root ball, and you have an NFT channel. Very little waste. So it's really a great system if you're trying to regulate cash flow. And yes, they are super, super easy to maintain. Kind of like playing with Legos. NFT cons. Because the roots are essentially growing freely throughout these NFT channels, and basically they're tubes for a better way to describe it. Once these roots start to grow, you may experience some type of breakage. Once that breakage happens, because you can't really see what's going on inside of these tubes, if you get root breakage or anything of that nature, a root ball buildup or anything like that, you're going to clog the system. Anything that makes it down in the water, to the water reservoir, could clog the pumps. We clog the pumps, we have a huge maintenance issue that has to be addressed quickly because we can't afford to starve the plants. We don't want to deform the plants in any way. Again, another issue with this type of system, and you'll find with most free-flowing water systems, magnesium. Magnesium. Our bodies need it. The plants need it. We deplete magnesium in our bodies faster than almost any other mineral source. And when it's one of the hardest mineral sources to put back into the body, okay? But it's highly, highly advantageous to make sure that we're getting it. But even more so, we have to make sure that we're protecting these plants and making sure that they have everything that they need so that we can viable production source for our end user product. Okay. Aeroponics. Now we're moving into space age stuff, right? This is like yeah, this is the mecca of grow systems. Aeroponics, essentially soilless. Roots are suspended. They're misted with a nutrient solution. The roots of the plants have no competition, no soil competition. They don't have to grow for anything. They're not fighting anybody for anything. So it's really kind of a neat concept. I myself, when I first heard of it, was like, yeah, nonsense. But once I actually saw it, it was actually amazing. You get quicker, more vigorous rooting. The roots do not have to fight for space, time, water, anything, because we just take it right to the plant. It's cleaner. You don't really have to worry too much about things like root rot or any other type of root fungus or anything like that happening on the plant, because we just missed it, and there's really no place for these things to grow and stick to the plant and affect the system, not too much. A lot less maintenance. You can build to suit your root ball. Different plants have different sized root balls. So if we understand the anatomy of the plant, then we can build an aeroponic system suited to each individual plant, and so therefore get ahead of the possible mistakes that can be made or possible errors that can come down the pipeline. Let's see, we have no need to purchase or prepare growth media, so we save a lot of money. As far as the types of plants, they're super flexible. Name it, pretty much, and it will grow.
Even a lot of root crops will grow.
Absolutely. Root crops, fruit bearing crops, leaf crops, all kinds of vining crops. The technology is strictly for the root system itself. And they do say that the cuttings for that are a little bit more robust. Say again, please?
You want to give them a little room to grow on, but the space is pretty compact still, yes.
Okay, when we look at the aeroponic cons, when you're transferring any type of loose fill, you gotta be very careful with these plants. Anytime you touch them, you need to move them, anything of that nature. It's best once you get it into the system, leave them in the system. Don't mess with them. When you have to transfer from your seedling operation, your propagation into the aeroponic system, just be very careful with the plants. Don't overexpose them to anything else. You're going to be ripping up everything that plant is used to. You're taking it away, and you're putting it into an alien environment. The plant's just as alive as anything else. So treat them with respect, and they'll take care of you. Increased startup cost, huge with aeroponics. Maintenance cost. These misters will clog like that. You get a little bit of lime buildup, clogged. You get some soil grain in the system, clogged. You have a clogged air emitter, those plants that are getting supplied by that, done. So it's relatively high maintenance. So the question that we'll look at kind of as a team is how can we prevent contamination, how can we detect buildup in the system, and how can we design the system so that these parts are easy to get to, easy to switch out, so that anybody that this young lady over here hires can just walk up to it and swap out parts as needed. We don't want to tear all the plants down. We basically kill, harvest, early harvest, something of that nature, not productive. So it's a pretty good challenge, but it's a reasonable challenge to face. Okay? The pump and the misters obviously can be a little bit noisy. So as I said here in the PowerPoint presentation, you may not want to try to sneak this into your bedroom for midnight snacks. The spouse will get a little upset about something like that. Let's see here. We'll move on. I'm sorry I'm taking so much time. We're going to move on quickly to just kind of starting with open source ideas. Some of the challenges that we need to come together and face as a team. How are we going to lay out the floor? We've got roughly, what would it say is for 40 by 40?
Yep.
So how are we going to lay it out? And how are we going to lay it out in such a way that it's protected for the user, but accessible to the general public? How can we make sure that they can really kind of get up close and personal so that little kids can come in and see that agriculture is becoming cool again because we're tricking it out to go on basically a spaceship, you know what I mean? We need to make agriculture cool for children.
Yes.
People are leaving the farm. Farmers are having a problem keeping their kids there to carry on their tradition. That is going to have an impact on us. So how do we make it interesting enough for people to want to take this type of technology back to the farm? Why would we not want this technology in rural America? It would create jobs in rural America, manufacturing these types of setups, installing them, maintaining them. It would save money on the farm. We use no farming equipment. It's a push cart. I can produce, with our system, 7 times per square foot of standard agriculture, using a push cart to harvest my goods. 7 times. That is phenomenal, and that's what we're going to do here. We're going to show people that we can produce hundreds of thousands of pounds of food on a fraction of the land. Fraction. That's tremendous. In self-contained systems that are going to help to prevent groundwater contamination with nutrients, added nutrients, fertilizers, things of that nature. That's a huge environmental issue. This type of technology can help to phase in some safeguards for environmental impact. Back on point, and I do apologize, we need to look at system types. We've covered 5 system types. They're good systems. They each have their own place. So we need to kind of collectively come together as a group and determine what systems we're going to use for production and what systems we're going to use for education and display. The water source. I've mulled this over in my head a little bit. We have no open water source there. So we're going to have to truck water in, or they're going to have to truck water in to feed these systems. So, like the way that we develop our systems, I would say that each system that my suggestion would be that each system be a recirculating system. Whatever water is in it is used and reused over and over and over again. The trick is going to be water chemistry. Once we start adding nutrients, we have to worry about nutrient breakdown, nutrient spoilage, and a negative effect on the system. So there's some science that's going to have to come into play with this, how we're going to take care of this water. Fail-safes, something that we talked about before. I'm a huge fan of redundancy. If everybody else wants one fail-safe, just ask Carol. I want 2. 6. I'm trying to be polite.